Alright, let's look at the homework 15.6, problem number 4. Alright, so we have part of a cylinder that lies inside the rectangle 0, 0, 8, 0, 0, 2, 8, 2. Alright, so first I'm going to solve this equation for z. So we have a z squared is equal to 9 minus y squared. Then we can take the square root of both sides. So we have a z is equal to square root of 9 minus y squared. Right? So since we're talking about the part of the cylinder lies above the rectangle, so I'm going to just use the positive one. Alright, so we just need to find the partial derivative of z with respect to x, which is an easy one because there's no x in there. So the partial derivative is 0. And the partial derivative of z with respect to y would be, right, so I'm going to rewrite it as a quantity 9 minus y squared to the 1/2 power. So put 1/2 in front and keep the inside expression as it is, and subtract 1 from the power, and multiply by the partial derivative inside, which is negative 2y. Right? So we can cancel here 2 on top here and 2 on the bottom there. Right? So we end up getting negative y over square root of 9 minus y squared. Right? So if you find expression, square root of, right, partial of z with respect to x squared, which is 0, and a partial of z with respect to y squared plus 1. So it's going to be square root of, alright, so that's 0, so that's a square, so it's going to be y squared over 9 minus y squared. And then we're going to have to add 1. 1 is a 9 over y squared over the same thing. Alright, so we can cancel y squared here and a minus y squared. So we end up getting, let's see, square root of 9 on top, so that's 3. And then we have a square root of 9 minus y squared. Right? For simplicity, I'm going to actually factor out this 9 and bring it outside. So square root of 9 would be 3. So we can have a 3 outside. Right? So 9 divided by 9 is 1. And negative y squared divided by 9 would be negative y squared over 3 squared. Right? You have still 3 there. So we can cancel 3 on top and the 3 on the bottom. Right? So this is going to be just a 1 over square root of 1 minus y squared over 3. Alright, so once we've done that, then we just have to integrate it over a rectangle. So our surface area S is going to be, right, so we have a double integral. Right, so this is rectangle is from 0, 0 to 8, 0. So x goes from 0 to 8. So I'm going to just put 0 to 8. And y goes from 0 to 2. So 0 to 2. Then we just have to integrate this. So 1 over, right, square root of 1 minus y over 3 squared. And I'm going to do it with respect to y here and with respect to x. Right? So this one is a separable one. So we're going to separate it into integral from 0 to 8, simply dx, multiply by integral from 0 to 2, 1 over square root of 1 minus quantity y over 3 squared with respect to y. Right? So I'm going to use a substitution. Right? So I'm going to let u be y over 3. Right? Then we can take the derivative with respect to y. Then we end up getting 1/3, right? And take the reciprocal both sides, dy over du is equal to 3. And multiply through by du, so dy can be written as 3u, right? So y is originally going from 0 to 2. So we're going to turn it into a u value. U value is going to be 0 over 3 is still 0. And 2/3. All right, so we got the 2/3. All right, so this integral becomes, right, so antiderivative of 1 with respect to x would be x. And then you're going from 0 to 8. Right, so I'm going to rewrite this integral as 0 to 2/3, and you have a 1 over square root of 1 minus u squared, and dy can be written as 3, oh, actually I messed it up, it's going to be 3 du, right? So I'm going to put the 3 du, right? Then I'm going to go up here, right? So if you're plugging 8 minus 0, so that's just going to be 8, right? 3 is going to be pulled out, and the antiderivative of 1 over 1 minus u squared would be arcsine of u. And then you're going from 0 to 2/3, right? So this is going to be, all right, so it's 24 times arcsine of plug in 2/3 minus arcsine of 0 is 0, so you just get that. So it's a 24 arcsine of 2/3. So let's type it in. Right, so we got 24 arcsine. So let's see, how do I do this? Arcsine. So here, -1 power, oh, actually, I'm not doing it, right, raise it to the -1 and 2/3, right, let's see, 2/3, right, so let's submit for testing. Oops. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.